Okay, chapter 4, oxidation, whatever, yeah, reduction. Okay, you have one, two, four, you have 6 questions. Okay, let's actually do this. Okay, fast. Okay, question 1: which of the following is a redox reaction? To know if it's a redox reaction, this will come 100% tomorrow. Uh, Follow the steps I will show you now. It has to do with oxidation number. Okay, oxidation numbers. Memorize the table here, which you will need, and probably another question come in. It's 25. This one over here. Okay, so over here, the most important ones are oxygen. Yeah, pretty much oxygen. And you should know if the oxidation number increased, it's oxidation. If it's oxidation number decreased, then it's reduction. Okay. Uh, so let's take a look. Okay, if it's an acid, okay, without using the oxidation number method, you can take a look. Oxidation, redox reactions have half oxidation, half redox. If you have a dissociation, guys, obviously it's not redox. Obviously, it's just dissociating, guys. This is gonna be wrong. It's not redox. There's no, it might be being reduced, but it's nothing being oxidized. So ZnO HCl. Also, any base plus acid reaction is always never redox. Let's take a look at C. Cu plus O2 is CO. Let's see here. Here, we don't know. So we're going to use the oxidation number method. Cu in this case is 0. Because if you remember, I explained it in my chapter 4 recording. Any element on its own or any compound on its own is 0. Okay, so that means copper here was 0. O2 here was 0. O here is what? -2. And since the total charge is 0 of this compound, how much should the copper be to make it 0? +2, because it's -2 from the oxygen. To make it 0, it has to be +2. So let's see here. 0, Cu was 0, it became +2. So that was oxidation. O2 was 0, it became -2. So that was reduction. So that means this is redox reaction. Here, D, Na2CO3 plus 2HCl. This is an acid-base reaction. You have an acid and a metal carbonate. Pew. Wrong, okay? Question 3. A zinc rod is placed in a 1 molar zinc nitrate solution. A copper strip is placed in a 1 molar copper nitrate solution. Okay, so let me try and draw this so you can kind of see. So you have a zinc nitrate solution, ZnO3. And you have a zinc rod here. Zinc rod. And the other one is copper nitrate. And you have a zinc rod, a copper rod here. Okay. The two half cells are connected by a salt bridge and externally by a voltmeter. The voltmeter reads 1.1 volts, and it shows that the copper is the positive terminal of the cell. Copper is the positive terminal of the cell. So which one's the cathode? Which one's the anode? Always the cathode is the positive terminal. So that means copper here is the positive terminal. If we're talking about galvanometers and if we're talking about galvanic cells, the positive one is cathode. But later, for the final, this is wrong because we're going to be electrolysis. That's something else. Okay. So over here, copper is a positive one, so it's the cathode, right? And then zinc is the anode. Quickly, we can write these things. Okay, and it's connected by a voltmeter, whatever. Okay, okay, which electrode is the cathode? Akid, it's the copper. The copper electrode. Let me just check the solution. Cu. Okay. Write the equation of the half reaction that takes place at the cathode. Always at the cathode, we have reduction. Okay. What is reduction? Reduction is gain of electrons, right? So we have Cu here. So what's going to happen? It's going to gain electrons. No, wait, what? Yeah. Cu is reduction, so it was 2 plus. And since we're gaining, it's going to become Cu solid. So it was aqueous. The aqueous ions in the CuNO3 gain 2 electrons, so it's going to change into Cu solid. Okay, always, this is how reduction is. You gain electrons, and obviously if you're going to gain electrons, that means here it should have a charge. And what's the charge of Cu, guys? You all know Cu is 2 plus. Okay, so this is your reaction. Let's double check on this. Yes, electrons don't have a state. Please don't put aqueous for electrons. Okay, which electrode is at the anode? Obviously it's going to be Zn. Write the equation of the half reaction that takes place at the anode. We know that's going to be oxidation half, right? Okay, What is oxidation half? Oxidation is loss of electrons, right? So Zn, we're going to be losing electrons. So if you're losing electrons, that means its product will have a charge, right? So it's going to be Zn2 plus, and to balance it out, it's 2E minus. Here it was solid, and it became an aqueous ion. Very easy. Okay, write the equation of the half. Write the equation. Write the write the equation of the half. Okay, no. In what direction does the current pass in the solution? Current always goes from positive to negative, so cathode to anode. Actually, no, don't memorize it from positive to negative. It always goes from cathode to anode, because later for the final you're going to do electrolysis, and in electrolysis it doesn't go from positive to negative. It goes from cathode to anode, even though the cathode is negative in electrolysis and anode is positive in electrolysis. So just memorize cathode to anode. Always cathode to anode. Forget about what I just said. And in this case, the cathode is zinc, and the anode, the cathode is copper, and the anode is zinc. Okay, let's check on our E answer. Cu to the N, absolutely. How much energy is okay? F is not required, but for those who do know, W is equal to QV, so you're gonna use the charge is 2 and the voltage is 1.1. But this is not required, so there's no need for you to know it. However, please do it anyways. Everybody knows W equals QV. Okay, W equals QV because energy is whatever. Okay. Question 4. 4 is required, yes. Given below is a schematic diagram of a simple cell. You have Mg and Cu. Knowing that magnesium is more reactive than copper, which one's the anode? Always the more reactive one is the anode. So the anode will be magnesium and the cathode will be copper. Write the cathode and anode half reaction. At the cathode, let's say at the cathode, cathode is always reduction. So that means reduction, you're gaining electrons. What is our cathode? Cu. So since you're gaining electrons, it will initially have a charge. It's going to gain electrons and it's not going to have a charge anymore. Aqueous. However, at the anode, it's oxidation half, right? Oxidation. And oxidation is loss of electrons. So since you're losing an electron, your product will have a charge, your initial one will not have a charge. So what's my anode? And my anode is Mg. If your initial one will not have a charge, it's what's solid. It's going to be Mg2 plus 2E minus, and this is aqueous. Deduce the overall redox reaction. For the overall redox reaction, you just combine these two, okay? So you cancel the electrons with each other, and what you're going to get, what are my initial reactants? There's Cu2 plus, aqueous, plus Mg, solid. What are my products? Cu and Mg2 plus. So Cu solid plus Mg2 plus, aqueous. What is the direction of the current in the external circuit? The direction of current is always from cathode to anode. What's my cathode, guys? My cathode is Cu. What's my anode? Mg. So Cu to Mg. I just want to make sure أنا ما مخبص. The anode is magnesium, the cathode is copper. This is the half reaction. These are the half reactions. The overall redox, okay. From the copper towards magnesium. Yes, because we said cathode to anode. What direction of the electron? Electron flow always moves from anode to cathode. The opposite. The anode in this case is Mg and the cathode is Cu. So it's going to be from Mg to Cu, magnesium strip to Cu. What is the direction of the ions in the salt bridge? You should always know that the cations move towards who? The cathode. And the anions move towards who? The anode. Okay, so the cations in this case, KCl, what's the cation? K plus. So it's going to move towards the cathode, which is copper. So K plus will move towards copper. And the anion, in this case Cl minus, is going to move towards the anode Mg. So let's see here. The cations move towards the cathode, whereas, okay, they just want it like that. Okay. It wouldn't hurt for you to add a bit more information. But yeah. Okay, we have question 10. No, 1, 3, 4, 10. Let's go all the way to question 10. Find the oxidation number for each of the following species. Okay, the total charge is 0. So, and I want to know nitrogen. You guys know hydrogen is +1 for each one. So 3 times +1 for the hydrogen. Plus the nitrogen we don't know. And equals how much? 0. So you're going to get H is equal to -3. Okay. H2CO3. The total charge is 0. You know hydrogen is +1. So it's going to be 2 plus 1, 2 times +1 plus C, which we don't know what it is, plus O3. How much is each oxygen? It's -2. So it's going to be equal to 2 plus C minus 6 So it's going to be equal to plus 4. Don't split it into CO3 2 minus and H2 because that would be wrong, according to my chemistry teacher. I2, it's an element in its compound. So what would it be? Directly 0. MnO4 minus, its total charge is -1, right? Let's start. Manganese, we don't know what it is. We need to find it. O4, it's 4 times each oxygen. How much is it's each oxygen is -2. And when you add them, how much you get? -1. Okay? So you're going to get Mn is equal to +7 if you solve this equation. Okay? You need, even if it's just 7, you have to put plus. Okay? Always. CR207, thank you to late Nasser Alaouni for helping me, by the way. In class, I was sitting and I didn't know, and he was correcting my paper, and he told me, Walid, you need to put the plus, because if you don't put the plus, guys, you're going to get it wrong, okay? You need to put this, okay? CR207, 2 minus. CR, it's 2CR, so it's 2CR plus 7O2, so 7 times -2 equals how much? -2. So you're going to get 2CR is equal to 12, so you're going to get CR is equal to +6. Let's make sure of these answers. You're going to get, let's take a look. N is equal to -3. B, because you need to find, by the way, why it's wrong is because they're asking for each element. So you have to show, okay, at the end you have to say, by the way, I should have written this, but H is equal to +1. And in this case, everything I used, and also I used O is -2, so O is equal to -2. Okay, so yeah, right, let's make our work more organized. So here I should have written O is -2 and C is equal to +4. And here H is equal to +1. Everything I used, yeah? Okay, and then here manganese, I used O as -2. And so this would be your answer here. This would be your answer here. This would be your answer here. And this would be your answer over here, because I used O as -2. O would not be -2 if it's with a peroxide, okay? A peroxide is H2O2. I explained this before. And also with metals and with fluorine, okay? But they never ask about these, but you should know them in case they do. Question 19 and 20. Let's take a look. Question 19. When acidified potassium manganate, oh, you need to know this. This is very important. When acidified potassium manganate is added to a reducing agent, its color turns from purple to what? Colorless. This is very important. When acidified potassium iodide solution, which is reducing agent, is added to an oxidizing agent such as chlorine or hydrogen peroxide, the solution turns what? Red, brown. Or I think it was shiny brown. I'm not sure. But anyway, so when you add iodide, it's reducing agent. When you add it to an oxidizing agent such as chlorine, it turns back to its original. It turns back to its original color. And iodine is originally shiny brown or red brown. I want to make sure. Oh yeah, red brown. See, red brown. 20. Given the following standard reduction potentials, which of the following would produce the largest voltage? Always the largest voltage would be the most negative with the most positive. Okay, so it would be AU plus Mg. It would be AU plus Mg, and AU, by the way, is gold, so it's going to be gold and magnesium. Magnesium and gold. So it should be B. Let me just double check. 20. B. The reason for this, why? You guys know that the voltage E0 net is equal to E0 oxidation plus E0 reduction, right? So this is E0 reduction. I need to add E0 oxidation. To find oxidation, I just flip it, right? And when you flip it, it turns into negative. So 1.5 minus 0.8 would give me a small answer. 1.5 minus 0.4 would give me, a good answer. If you change this now, it's going to become positive. So 1.5 plus positive 0.76, it would give me a good answer, but it would give you the largest answer for when you get this. خلاص, انت whenever you see largest voltage, always take the furthest two from each other, okay? Are we done here? Yes, we are. Thank you so much for watching. Good luck in your chemistry periodic, guys.